You guys see it?
Yes. So when you're ready, you can start.
Okay. Hello everybody. My name is Abnezer Tefera. My project I'm working on is I'm trying to create a vehicle depreciation prediction model. So basically, trying to predict uh, the value of a car at a given point, like based on depreciation. Um, so purchasing a car is a really big investment for a lot of people. Um, Although it's an investment that enables them to do many things, it's still a depreciating asset. You're still more likely to lose money than not. It's very rare that a car appreciates, but you still want to minimize how much money you lose uh, if you ever want to resell the car or just keep the car, pass it down. Um, So that's why when you purchase a car, it's very important to look at not just how much you're paying now, but how much it'll be worth in the future. Since a lot of cars lose their value at different rates based on a bunch of different factors, um, the goal of this project is to use machine learning algorithms to be able to predict how much they depreciate, um, and I'm going to be doing that using a data set provided by TrueCars.com, and in hopes to provide reliable information about the future value of the car. So plans. So step one is to actually obtain a data set so that I can base my model on it, so I can train my model. After you obtain it, after you get your data set, you want to prepare it to actually be passed through, because um, it, more likely than not, the data is not exactly neat or clean. For training or testing, it's not very organized. And then after that, in order to determine what type of test and how I want to set up my neural network, I want to actually perform grid search or random search just to figure out all my hyperparameters, and then also I need to actually find out my parameters as well. After I do that, there are a couple of different models that I want to try out and train to see what the most optimal model is. There are a bunch of different ones, like SVMs and polynomial regression models. And then after that, um, the final step is to basically create a report based on my findings on based on the results of those models and the accuracy. So step one, data collection. So I found my data set on Kaggle. Kaggle is basically just a website full of data sets. If you guys aren't familiar, so the one I found was it was a CSV file filled up with 1.2 million used car listings from TrueCar.com. They were collected. Excuse me. They were collected in 2018. So the problem with the data set, let me go back. As you guys can see, it's the model number. It's all just one long string. So if you want to just look at encores in general instead of like specifically the front wheel drive or the convenience trim, it'd be hard to differentiate the two based on this. So I needed a different way to actually expand on this information to make it more neat. Um, so luckily they provided VIN numbers, and I found an API provided by NHTSA, which basically decoded the VIN number. So you pass them the VIN number, and then it returns you how you can get it however you, and if you want a JSON, you want CSV file, whatever format you want, they return it to you that way. In my case, I wanted a CSV file because that's what I was working on with pandas. It's what I'm familiar with. So these are all the uh, parameters. So this huge array is basically all the elements in the array, like all the possible values that get returned for every single VIN number. As you can see, that's a lot, a bit too much, and not all of it is completely relevant. Like there's like motorcycle suspension types and motorcycle chassis types and things like that, where it wouldn't really be applicable here. Um, there was also a lot of like just null values and just like useless information or no information in a lot of these columns as well. Another problem was the actual data set and the NHTSA API. Neither of them actually provided MSRPs for the car, so you wouldn't be able to determine a starting point for the like a starting price for the cars to see where they started from to see how much they depreciated, because you would need that information. When I first started this project, um, this wasn't really that big of a deal. Like I assumed, there'd be, an API or a database or some way to just write a little script or something, and I'll be able to access it, or it'd be provided. But actually, there aren't any. So I first thought I'd be able to use web scraping to go on Auto Trader, because they actually have a pretty simple way to send a link. So and it'll return. It should have returned a like HTML file with like all the data for the web page. But as you can see, they have like bot blocking. So I'm not like sure what the technical term is, but basically I can't write a script to web scrape their website in order to get the MSRP. So I was looking for other methods. I tried looking at Kelly Blue Book. I tried looking for APIs. Actually, Kelly Blue Book did have an API. I reached out to them because you have to like go through them. Unfortunately, they said that they were only looking to give their API. They were only looking to give access to their API for people who wanted to use their tool for commercial purposes. And because I preemptively said I was a student, I couldn't finagle that. Um, so I had to resort to manually entering or looking up the MSRPs. So originally, I wanted to do MSRP of different cars based on year, make, and model, but I didn't want to Google 11,000 entries, so I just did make and models for my sanity, and even that, I mean, it was about 1,000 some change, but it took a while, but uh, that was done. Finally obtained that. After I obtained the MSRP, after I got all the other supplementary information about the different cars, in order to, there are a lot of string values associated with the car, like the make and model, for instance. So in order to pass your pass elements into a sorry uh, a model. Sorry about that. In order to pass your features into a model, it would need integer values in order to actually be able to understand what it is that it's being passed. So in order to do that, you can encode your data. So originally, the data set itself already was humongous. It was I got it down to like I want to say 30 features, and then there were like 1.2 million listings. From there, I deleted a bunch of like redundant or like rows that didn't have enough information. So like some cars just had a blank make, so it'd just be like the model, or they wouldn't have anything under like their sale price or something. So things like that, unusable data, I removed. So at this point, I had about, it says it right there actually, uh, a little more than 1 million listings. Um, so after I encoded the data, the 30 30 parameters or 30 features turned into 300,000 because the way the encoding works is for each individual value in that column, it'll turn that into its own column so that it'd be a Boolean. So each column would have, so say there's a Honda, Toyota, and a Subaru. Um, Instead of each of them being in that single make column, it'd say make Honda. And then if that row is a Honda, it'll have a one. If it's not a Honda, it'll have a zero. So that increased the number of features and required me to have, as you can see here, it asked for 2 TB. I think that's what it was. It's not terabytes, um, of RAM, which I don't even have that much storage in my hard drive, so I wasn't uh, able to run the polynomial function here like this. I was able to run a linear function, but it's not really that useful because there are more than 2 features. Um, so it would be hard to analyze that that data. So I had to resort to eliminating a lot of columns. So what I sorry. So I had to downsize the data. So I again tried just, the mileage, the model year, the MSRP, sales year, which in this case they were all posted in 2018. That's why everything for the sale year is 2018. Um, the state, the make, model, and so I did the state because I know certain regions might have different climates that might affect how like worn out a car can be. So that's why I chose to include state. But even still, it was I couldn't run it, so I had to just eliminate states as well. So now I'm using just the make, model, MSRP, model year, mileage, and price. So once I got to this step, uh, it's basically trying to find out what what parameters and hyperparameters you need in order to set up your neural network. Um, so keep pressing the arrow. Sorry. So so I attempted to set up the network with Keras with a Keras library. I just typed a couple of add a couple layers, some activation functions, just to see how accurate I could just randomly get it. Um, as you can see, it wasn't accurate at all. So I decided to use a grid search in order to get the optimal parameters, and that's where I'm at now. It's been a couple of days, and it's still going. I'm deciding whether I want to cancel or the grid search and just resort to random search because I know that is a bit faster. Although I did want a more accurate hyperparameters in order to get more precise like output for my model because I only have one output. Although I'm like, as I was thinking recently that it might be better to do a range instead of a single number because it's going to be extremely difficult to predict the value of a car to the dollar. And it'd be very unlikely for the actual model to have any decent accuracy rating with that. Oh, I keep pressing the arrow. So remaining work. So using the hyperparameters and the parameters from the grid search, I plan on testing my data using support vector machines, polynomial regression, principal component regression, and partial least square models. As the picture here is actually a partial least square model. So that's basically, it's just this and then my report, and then I'll be finished. All right, that's basically it.
Okay, questions, please.
Oh, I have a question. You said that the machine learning model wasn't accurate. How do you know it wasn't accurate? Was it giving you like an error message?
So if you see, let me see, where is it? Right here, it says accuracy. It's at 0%. It's at 0.
Oh, gotcha.
Yeah, so it gives you a score. It'll tell you right here.
Oh, okay.
Yep.
So normally the accuracy is different. So what I mean by that, the different. If you select some of the data samples and then that data sample doesn't have the exactly same kind of testing data, then the accuracy it turns out the 0 values, right? Because similar kind of pattern doesn't exist in the testing or the training sample.
Mm-hmm.
So that often happens. So that's why people normally not consider accuracy that much. So instead, they're trying to use some other value, right? So recall or other kind of measurement they're trying to use.
Can you say that again? It kind of cut off.
So if you simply think about the recall, so that's going to be the true positive, true false negative, those kind of all consideration it should be. So depending on what is going to be important, you can simply think about different kind of measurements instead of accuracy measurement, right?
Mm-hmm.
So you can easily find those kind of things. However, so I mean, since this is continuously going on kind of stuff, like you have not actually found the conclusive result, then you should definitely think about considering other measurement instead of accuracy, because here you define the metric as accuracy, right?
Mm-hmm.
So instead of accuracy, so if you're defining so here the recall, it also calculates different kind of result as well.
Okay.
So it depends on. So I'm not saying that recall is going to be the 100% accurate metric.
Yeah.
Right. So depending on the data type, so the different kind of the measurement is going to be good. So what I mean by that is, so in your case, accuracy, if it turns out 0, that means calculating the accuracy is not. It doesn't mean anything. So
Yeah.
in your data set case. So however, some other data set case, accuracy might be important measurement, right?
Okay. Yeah.
Any other questions, please? All right, thank you. So let's move on to our